thing here at the moment, so
Right, recording in progress, right? So, here's relational theory, yeah. And what I've done here is I've mapped this to the 5 Chinese elements as well, because the mapping is essentially perfect with that that philosophy, that set of concepts. So things in the universe, everything in the universe is a source and sink of signals and data. And when those signals interact with something which is capable of receiving those signals, there's an informational event. Yeah. Now, those informational events have an impact on the things which are receiving that information, and it actually changes essentially their knowledge, their cognition, awareness, their state of, let's say, presence, if you like. Yeah. Now, when you get that state change in terms of knowledge, forces then come into play. Forces of attraction or repulsion, for instance, which then have an impact on the mass and energy of material things, and new things come into being, which are a new source and sink of signals. So this is the pattern which is going on everywhere all the time. Yeah. And this, as I say, this also relates to the 5 Chinese elements. So metal is essentially the things in the universe. The informational events is associated with water. The knowledge is associated with wood. Forces is associated with fire. And earth is associated with the mass and energy of material things. And Thomas Wong, who's a medical practitioner, he's a doctor. He blends both Chinese and Western philosophy in his holistic practice. And he used these terms. So he associated water with awareness of changes, wood with cognition, fire with emotions, and earth with behavior. So that's really quite interesting. I think there's more to be explored using this framework as well, because as well as having the flow, and this flow is consistent with relational theory, what's also interesting is they have overcomings interactions as well. And I think there's something to be done looking at these overcoming relationships, particularly in engineering, to help us potentially deal with some of the pathologies that we see. Now, the dream I had was about combogenesis, and how combogenesis could be perhaps used to illustrate this more clearly. Because if when you first encounter this seems a bit weird. So combogenesis is, you've got these parts, things and relationships at a prior level, and through combogenesis, new things arise, and you can see new signals. So I was thinking about using this model in relationship to relational theory. So that's what I've done here. And essentially every spin of this holon results in a higher level of abstraction of systemness. So here we've got 4 parts, and those 4 parts come to make a new whole, which has new signals. Now, here we've got these 4 parts essentially in chaos. Yeah, so they're all moving around potentially randomly, but signaling starts to arise between these parts. So a signal is being sent and received, and there's essentially an informational event. Yeah, so this could be any kind of signal. Typically in our levels of abstraction, it's either information or it's electrical in nature. So when these things receive the signals, their state of awareness changes. They move into a different state of awareness. And I explain this in the paper that we did, Suja, where a photon has been released of the right frequency to basically move the electron from one orbital to a higher level of orbital. And what's happened there is that these, in the case of atoms, they're now at a higher energy state. So essentially their knowledge structure has changed. Now, as a result of that knowledge, forces start to come into play. So there's now an attraction or a repulsion, in this case, an attraction between these things. So forces are now coming into play in this segment. And when those forces then come into play in terms of forming the bonds, you've now got the new thing. And in terms of the whole, you've now got new signals that are arising. Yeah. Now, I've also added on to, so chaotic influences, a heightened state of awareness for complexification, forces come into play, and then physical things take up new forms. And that's what happens with essentially every spin of the holon in the context of new levels of systems coming into play. But we also see this, in any system transformation within the levels as well. So, in a social system, for instance, we all know that unless the participants in a social change are properly prepared, the change doesn't happen because it's just rejected. So you have to give the participants in a social change some sort of experience which raises their level of consciousness such that the change can actually happen. Because if you just try and force things to happen, through dictatorship, it doesn't necessarily work. The people have got to be prepared in order to enact the change. So I've also added on structures and functors. And so maybe now we can see what's going on a little bit more clearly. In terms of what a structure is, maybe the question is, how does physicality provide information? And maybe we can then start to think about what a structure actually is. And up here we've got, how does essentially knowledge generate or provide power for change? Because that's essentially, I think, what a functor is. But I don't know. Yeah. So what I then thought of was, okay, wouldn't it be nice if for every single one of these levels we could explain what's actually going on in terms of the signaling, the change in state, the forces which come into play, and the new holes. I think that would be really interesting to do for every one of these levels. And I put that to Tyler and John last week. But it'd be great if we could all work on a paper together on that. So I then wondered about the standard model of physics, that first level of abstraction and what was going on. So I listened to quite a few sort of YouTube videos from theoretical physicists and on quantum theory and all that kind of stuff. So this is a model because we don't really know what's going on, but essentially, at the very lowest level, there's the fabric of space-time. Yeah, and one of the mental models which seems to serve quite nicely is that essentially it's a load of balls on springs, and these are vibrating randomly. Yeah, and we see this in the quantum field interactions which have been simulated. But these are the parts. The parts are essentially what you might call I can't remember the term. It's mode. It was conceived by someone in I don't know 18 something or other, but basically these are noughts and ones, and when these vibrate together, you get sort of like wave functions arising. Yeah, and it's probably no coincidence that the quarks are up and down, and at the highest level of frequency you've got tops and bottoms. So imagine all of this stuff vibrating. Now, when things start to vibrate together and you get essentially wave fronts, this is where these conceptual things start to come into play. So a down is the first level of down in terms of a quanta, and up is the first level up. Strange is a little bit is the next level down. Charm is again the next level up. The bottom is the highest level we've managed to experience so far, with the energy we've been pumping into it, and the top is the highest energy in terms of quark. So this is literally ripples in space-time, as a result of, you know, the random things coming together, and you know, you're getting these fermions formed. Now, fermions have no physical presence on their own. They have to be combined with other things. So this fits really nicely in the context of the contextual system. Yeah. Now, we know that gluons provide the interquark force. So when these things arise, and you know, and they're in the right place, essentially in space time, the gluons are the things which bring them together to then form the nucleons, so the protons and the neutrons. So, you know, a down and two up is a proton, two downs and an up is a neutron. So this is now where we start to see the mass and energy of actual material things. Now, I suspect that the same kind of thing is going on with electrons, muons, taus, and the leptons as well. So I think from what I've seen, there's when an up switches to a down, there's another relational diagram, but it's to do with essentially these things switching from one state to another. And I think it's the bosons which are the forces which arise, but those forces then essentially create the electrons, the muons, and the tau, which again are the actual physical things. So, you know, this is essentially a nucleon, a nucleon, and you know, with the elements with the electrons as well, you've now got, you know, the new whole, which is the atoms. So I think it's potentially a useful perspective to take on the standard model, because the standard model shows that there are things in terms, and these are all perceived as particles, yeah, but it's probably only these it's probably only these things which are actually physical. This is simply conceptual. So looking at the standard model in this way, we may be able to get some insight into the actual mechanism that's going on. So, you know, there were a few questions which arose because of that. So I think there's quite probably a separate hodon that explains the leptons. I came across a really interesting principle called Landauer's principle, which is that forgetting information is the source of entropy and time. And there seems to be, therefore, an implication that this stuff, you know, this really low-level stuff, electrons, protons, and neutrons, they don't experience time because they're not losing information. You know, a proton is, you know, there's no decay of protons. Protons are just forever, you know, unless they end up in, you know, a black hole. Yeah. Neutrons do decay, but neutrons only decay when they're isolated. So, you know, why is that? We don't know. Yeah. Why does mass curve space-time and create what we observe as gravity between things? Well, if mass results because of the amplitude of the ripples in space-time, might not accumulations of mass generate? Is that why mass generates gravity wells? Because it's essentially, you know, a collective ripple in space-time. Quantum foam has been postulated as the fabric of the universe, and it's constantly blowing bubbles, which is really interesting. As well as amplitude, quarks have spin. Yeah. Now, could it be that other orientations exist, and that we can perceive in the universe only that which is in accordance with our orientation? The other 96% of the universe we can't detect. So that's really interesting to look at. And, you know, as I said, you know, at the atomic and subatomic level, there's no loss of information, no time passes. But why do unattached neutrons decay when protons do not? How does time pass for radioactive substances? So these are all things that I think are worth talking to, you know, theoretical physicists about, to try and get, you know, maybe some new understanding. So yeah, so that was the train of thought, basically. So I just wondered what people thought of that.
I've got a question.
Yeah,
that I mean, in the diagram, you have contextual and actual systems, but when you
Yeah.
were talking about conceptual and physical systems.
Yes.
So I was wondering why the difference.
Well, the conceptual is related to information and essentially changes of awareness. Yeah, it's consciousness. Everything in the universe has a level of consciousness. In order for consciousness to arise, there has to be some physical presence. Even potentially when we get down to the foam, which is the the very fabric of space time. Yeah.
So why in
maybe
the
I could add,
slides are you
yes,
calling them contextual and actual instead of conceptual and physical?
conceptual.
That's just the way it was called in the relational model. That was Rosen's
Okay.
terms. Yeah.
Oh, okay.
Yeah. But I think that left-hand side of the diagram is essentially consciousness. Yeah. It's the sensing, it's the gather of information, it's the appreciation of your state and the state of things around you. Yeah. Because the lowest, the most simple definition of consciousness is an awareness. Yeah, an awareness of one's surroundings.
Right. I've got a couple of quick thoughts, Gary. Maybe I don't know. Can you hear me okay? I don't know. My lines are really bloody bad here.
Yes,
Yeah.
great.
So first of all, really fascinating. I really like the way that you've structured it, and it sort of resonates. And Cynefin really is a great sort of framework to go on. But lots of thoughts were coming to mind there, and I know I need to go back and really look at the standard model again and understand that. But I think the three sort of things that really stuck out to me as you were going through this, right? One was the concept of entropy. And you then touched on it, and it's something that I've always sort of struggled with, to get a sort of a really sort of understanding that makes sense of entropy, because it seems to go against the grain. But I think this is providing some sort of shaping of that. And in that regard, the other point that you made, that fundamentally the universe is an emergent it's an emergent concept, and the thing about control, right? So it's about at the conceptual level, there are this forming happening, and then there's resonance happening, and as that resonance finds greater resonance, we find relationships building up, and those relationships then reach a certain critical point that then causes them to become really strong relative to everything else, and they take shape and form. And perhaps another way to look at that diagram is on the left hand side is the conceptual or contextual, whatever you want to call it, but it's consciousness, as you say. And on the right hand side is where it becomes perceptible in our four-dimensional time-space reality.
Yes.
And through the senses that we can then measure it, right? We can touch and measure it. Whereas on the left, it's in the making, but it hasn't transitioned into perception yet. So it's conceptual but not perceptual. And then we bring it into perception, and now we can touch and feel it. And if you sort of abstract that back to systems engineering, the conceptual models of systems to the tangible that we then create. I mean, a long story, right? But really that's fascinating, right? So the concepts of entropy, the concept of the conceptual and the perceptible, and how they separate, and we bring that in, and the other concept that was coming across is the one that I've sort of used before, right? It's from a modeling and simulation construct. It's about abstractions. It's about how these abstractions are starting to form, and then there's relationships that start to exist amongst them, that start to make sense, and that shared sense of awareness as you sort of go clockwise from the left around to the right, which is the Cynefin concept as well in that regard. And how modeling and simulation could complement that understanding of as we go around this and result in the tangible. I mean, there's so many layers to this. It's a fractal pattern inherently that I think you're touching on over here, right? It's a fractal pattern that repeats at any sort of layer from any perspective that you want to look at it. And so really, fascinating. I must go back and look in a bit more where I can actually see the screen a bit better. But it's exciting. Really good, Gary.
What intrigues me from listening to that is the step between it being conceptual in a single person's brain and it being a shared concept, and that shared concept in time becomes part of, shall we say, the shared wisdom. In other words, there's a relation. Learning to, it's basically reveals the importance of learning together.
Yes, it does.
That on its own, it's nice ideas. It's, if you like, your dream. But as it becomes shared, so it begins to get embedded in the collective. I'm going to use loose words, in the collective wisdom, which is knowledge.
And there's a threshold almost, Patrick. There's a magic threshold for different types of knowledge and wisdom that only sharing can bring them into reality. Otherwise, they never make it across. It's the sharing that causes them to emerge.
Absolutely. And this you go right the way back to Lewis Carroll in this. I mean, Lewis Carroll in his Through the Looking Glass and in Wonderland, Alice in Wonderland, is actually talking about the same thing, only he's poking fun at it and playing with it. But I think it's the Red Queen is a purely imaginary idea, actually. Do you see what I mean? It never actually gets into the physical world. It's except when Disney deals with it. But in the way in which it was originally written, it was conceived in his mind as a question, and that it's those questions, just as your questions are if you like, the force, the source of inspiration. Does that make sense? I know I'm muddling ideas up, and I'm sorry that you maybe coming away from the mathematical correctness of the thing, but I think we've got to understand how it works between people, and because the ability to share it is, in my view, absolutely fundamental to progress.
I think it's an absolute property of this process. I think, Patrick, that you're touching on. It's the property of that creates the emergences. It's almost like there's some sort of a relationship here in terms of the types of things that emerge, or the characteristics of, or the elegance, or I think it's got a lot to do with elegance and beauty and structure. It's almost like the more you get collective, the more elegant and beautiful and powerful is the concept that comes out of it.
That's interesting. Is there something in information theory which says the more simple the relationship, the better it is? Simple might not be the right word. Clear might be a better word, actually. Yeah, perhaps clear. The clearer the relationship is, the more beautiful it'll be. Is there something there? I'm just toying with it at the moment.
I'm guessing there might be, but I can't go to sort of give you a definitive. But I think there is something in that.
Okay.
There's a quote about there, isn't there, in design? There's a quote about that, like simple elegance or something like that, or the elegance of simple solutions. I can't remember what the quote is.
You're getting very close to the sort of design theories and things like that, isn't it? The theory of how design is done. But this, it's as you said, it got clearer and clearer to me that this is really also about how we think about things, and part of things only ever exists in the way we think about it, and part of it exists in the physical world. And that's why I was talking about ghosts earlier enough. I'm sorry, I'm probably distracting everybody from train of thoughts are on. Sorry.
I think it's all part of the emergence, Patrick. I mean, we're all saying things that are sort of bringing things up in others because it's sort of it's the model that I guess Gary's. We're demonstrating part of that model in a sense because you're finding resonance and relationships are collecting, and we're slowly moving across, right? As that happens and concepts are forming.
Yeah.
Right.
This is happening at the moment.
Yep, exactly.
Yeah.
Now I just need to go back and refresh my mind on what the hell that standard model really is, because I always had trouble in the esoterics of it. And was the model the model itself is an abstraction. And the point is, what sort of an abstraction is it? Is it a literal abstraction or a figurative abstraction in some sense? And that's the bit that I never could get my head around, and I need to get my head around that, I think.
What one can say, I think, JB, is the model is an abstraction, but the model is an abstraction which has become been tested many times and still stood up. I think that this is where the scientific process is relevant in this. It has a validity because it's been tested in many times and is still valuable. I've hesitated to use the word correct because I think you'll find that correct might be a little bit misleading. That it's valuable and consistent. Maybe it might be an important word. Consistently believe works. This is where the mathematics.
That's right. We can use it to extrapolate and predict. That's the point, right? And that's why it works. Yes.
Yeah. Well,
usability is important.
Yeah.
So what I'm wondering now is if a systems perspective, I wonder if the system science, if that model could actually bring some new insights, or raise some new questions. That's why I want to have a conversation with a theoretical physicist. There's a guy called I think it's David Tong, I think, at Cambridge, who's done a lot of public and also very professional videos as well. He seems to be quite approachable, so I might try getting hold of him and seeing if we can have a conversation with him.
I'm seeing worried faces. I'm wondering why.
What, here?
On the screen.
I've got to go in a minute.
Same here. Sorry.
But it works. Like, it seems to be only covering part of the story, if that makes sense, because you go through the cycle if you decide to end up like joining up, if that makes sense. Like it shows the molecule forming, or it shows the team forming, but that's not always what happens. And I remember you were talking, I think it was in the top left corner, about how they see each other and then they decide that they're gonna the forces are going to make them combine or whatever, but that's not always what happens. So what happens?
No, that's right. Yeah.
Yeah.
So
it doesn't feel complete to me.
Yeah, no, that's the positive cycle. So there is a negative cycle as well, and the negative cycle is the shadow cycle. We see that in our social systems as well. So I'll just flash it up really quickly because you've seen this before. Yeah. So this is the positive cycle. Yeah. But there is also a negative cycle, which is always working in opposition. And the negative cycle is also important because this is the cycle that basically stirs things up, and can also be a motivator for change. Yeah. Because if it wasn't for all of this crap that's going on in our social systems at the moment, there would be no driving force for a greater level of consciousness in terms of, the planetary whole. Yeah. So the planetary whole won't come about unless
I have to
there's
go now. I'm
all of
sorry,
this
guys.
frustration and pain around it. Yeah. Okay. Thanks, Charlotte.
Hi, Charlotte.
Yeah. And this is also what's going on in our heads all the time as well. You know, we have our shadow side, which is constantly nagging us and telling us, you know, how crap we are. Yeah. Or you can't do that, you know, you'll never be able to do that. Yeah. You'll never change the world, you know, whatever. Yeah.
Well, it's very interesting because actually that is one of the things that really holds us back, because there is the negative side is actually a very strong and necessary component of engineering.
Yeah.
It's necessary because the consequences of getting stuff wrong. I mean, it can be very, very substantial. But on the other hand, you have to have this where you're really arguing for why we have to have hope. And we do have to have hope if we're going to innovate and move forward. And there's a real demands for that, because otherwise things would be at times too ghastly. But yeah, I think this has been great. You've recorded that. Will you?
Yeah, well, I'll distribute it.
Distribute it. I thought that was a lovely half-hour piece to reflect on, go back over and see where we get to. You've put forward a proposal, haven't you, which is that we should go forward in some way.
Yeah, I'd like us to work together on a paper illustrating all of the 12 levels in the grand sequence. Yeah, and relating that to relational theory. That's what I'd like to do. Well,
that would be fantastic, because you'd have the vignette for well, the question in my mind is whether that should first become a blog and then a paper.